In our last video, we spent a lot of time talking about domain and range, and we want to continue with that today. We said that domain was the independent variable, the values that we use for the independent variable. Frequently, that is X, but not always. We talked about a scenario like the population in a city over the course of 10 years, that the variables we would have would be P and T, and we would need to figure out which one was independent and which one was dependent. We said that the population would depend on what year it was, and so the population would be dependent and the year would be independent. So domain is the input value or the independent variable, and if we have X and Y, it is the X value. Range is the dependent variable, the output, and if we have X and Y, it is the Y value. So when we look at these ordered pairs for this function, if they ask us for the domain, then we can pull that first value, that input, 3, negative 5.6, and then the range would be that second value, the output, 1, 9, and negative 3. Now, your domain is going to be all real numbers unless one of two things happens. Number one, you have a 0 in the denominator, because what's 0 in the denominator? It's undefined. Or number two, you have a negative under an even indexed radical. The index, remember, is what tells you if you have a square root or a cube root or a fourth root. So if that number is even, like a square root or a fourth root, you can't get a negative under that, because what's a negative, like what's the square root of negative 1? It's an imaginary, right? So when we're talking about domain values, input values, we can only use things that are going to give us a real output. We can't have undefined or imaginary. So, for example, they asked me to list the restrictions for this function for 2 over x. All right, so your domain is going to be all real numbers unless you have 0 in the denominator or a negative under an even indexed radical. I don't have a radical, but I do have a denominator. And so that denominator cannot be 0. And so that's going to be our restriction. X cannot be equal to 0. It could be anything else. All right, look at another one of those. So for this one, again, I don't have a radical, but I do have a denominator. And I'm going to say that denominator cannot be equal to 0. Now, the other thing that we frequently have to do, instead of just giving the restriction, often they'll ask us to tell what is the domain of the function, as opposed to what do we have to exclude. They'll want to know what values do work for that function. And let's do that in interval notation, all right? So if we have all real numbers except for 0, that means we're going from negative infinity to positive infinity, excluding 0. So here's how we write that. We say that we're going to start at negative infinity and we're going to go to 0, but we're going to have to stop there because there's a problem at 0. 0 can't be included. So if I can't be equal to 0, am I going to use a bracket or a parenthesis? I'm going to use a parenthesis. All right, then I'll jump over 0 and pick up on the other side, and I'll go to positive infinity. And of course, we always use a parenthesis with infinity and negative infinity, and the little union symbol just shows us that we're uniting these two pieces. All right, for the next one, where we said x plus 1 could not equal 0, subtract 1 from both sides, and we find out x can't equal a negative 1. So that would be all real numbers except for negative 1. So that interval notation is going to look exactly like this one. It's just that in the place of 0, I'm going to have negative 1. So again, negative infinity to positive infinity, excluding that negative 1 and the union symbol in between. All right, look at the next one. So for the next one, do I have a fraction? No. Do I have an even indexed radical? Yes. When there's no number here, that's a square root, right? That's a 2. So that is a radical with an even index. So we've said that it cannot be what? It can't be negative. Okay, so what can it be? Well, it can be positive or it can be 0. So we're going to take what's under the radical and we're going to set it greater than or equal to 0. So again, what's underneath that radical can't be negative. It can be positive or 0. And so that's what we're going to say. What's under the radical has to be greater than or equal to 0. So if we solve that inequality, we'll add 5 to both sides, and we'll get x is greater than or equal to 5. All right, so interval notation for that, what is the 5? Is it your smallest value or your largest value? It's our smallest value, and then we're going to positive infinity. All right, what are we going to put with the 5, a bracket or a parenthesis? Because we have equal to means bracket. We always put a parenthesis with infinity and negative infinity because we can't be equal to them. All right, look at the next one. So your domain is going to be all real numbers unless you get 0 in the denominator. Do I have a denominator? No. Or a negative under an even indexed radical. Do I have an even indexed radical? No. If you'll notice, that index is odd. Y'all, you can take the cube root of anything. Like the cube root of positive 8 is 2. The cube root of negative 8 is negative 2. The cube root of 0 is 0. There are no restrictions on a cube root. So we said your domain's going to be all real numbers unless one of these two things happens. One of those two things didn't happen, so my domain is all real numbers. This is the symbol that we can use for all real numbers. And then this is our interval notation, negative infinity to infinity. All right, let's look at another one. So for this one, do you have 0 in the denominator? No, I do have a fraction, but there's no way that that 2 can equal 0. See the difference between this one where we had x in the denominator and we could get 0 there? I can't get 0 in this denominator. All right, do you have an even indexed radical? No, I don't have any radical at all. Okay, so then what's your domain? It's all real numbers because again, it is all real numbers unless one of two things happens. Neither one of those things happened, and so my domain is all real numbers, and again, that is our interval notation for it as well.